So good afternoon. How's everyone? Okay. Good, and I'm hoping you are having a good show. And if you are here, I guess you must think about IoT a lot. You must having some personal observation about the big shift that may be happening in your industry. You may be having questions, what does this transformation that's driven through a fully connected world means to you? You may also ask, this process seems complicated, where should we begin? So my name is Satyen Yadav. I'm a general manager in Amazon, and I lead a division where my team drives innovative products and services to specifically answer these questions. So in this session, we will explore what Amazon is doing to help you respond to these new environment, new business challenges, where you're expected to meet customer expectations that are evolving rapidly as the IoT grows. So you may have seen this chart where analysts are predicting billions of dollars, billions of units connecting to internet. And you may have also personally observed that things in your personal life are all connecting to internet, whether it's things that you use on day-to-day basis, the other things that are not connected yet, or the overall environment. Essentially, we are heading towards a fast transformation towards a fully connected world. But you also say that IoT is a buzzword of technology industry, which is true. But at the same time, you may have personally observing what's happening in your industry, and it is an undeniable reality for your own business. What it means is how do you evolve your business to meet customer expectation, whether you're part of healthcare industry, agriculture, industrials, public sector. It doesn't matter which industry you may belong to. My expectation is you are answering facing some of these questions today. So what we would do, we'll explore what Amazon is doing in this space. So before I go there, I raise a few questions for ourselves. The end-to-end solution that we need to put together, they're complicated. Beyond just having these internet devices connected, you may be asking questions yourself, what are the things that I need to do? What are the steps? How do I build these devices? How do I bring the intelligence that they connect to the internet? And once it's connected to the internet, what it means. Certainly securely connecting to the internet would be one of the requirements. But what it means to once I have the data, what do I do with this data? How do I analyze it? How do I visualize it? And most importantly, how I generate insight that is useful to you to develop new products and services. And you may say, hey, is there any better way? Do I have to worry about all these problems? Do I have to hire device engineers, cloud engineers, and go through the end-to-end? And you would actually rather work on solving your specific problems. And whatever industry that you may be part of it, there is specific knowledge needed to solve problems in that industry. Those could be improving your own current products and services. So how do I use the data that gives me insight, how the product's being used today, and what must change to deliver a better experience. The other things you may ask yourself, are there better ways to do the things that you have been doing completely new, innovative way to develop products or come out with a new set of experiences that you want to deliver to your customers? And some of our customers are exactly doing that. And in this session, we'll be demonstrating these customers how they're using our products and services. So before we go into the specific solution, one of the other questions you ask, how do I connect the dots? There are lots of things I need to worry about. And so we say there are three pillars of IoT that you may have to consider. The first pillar is the things, or the things that you put out. They're certainly doing lots of functions, but also sense and taking some action that you want it to take. Then you want to connect those devices to the cloud, where you want to store the data, process the data. And then finally, once you have the data available to you, then you want to draw some intelligence from this data. What insights you could draw that you could act upon. So in this session, we'll go explore deeper into the first pillar, which I believe is one of the most important pillar, and that creates a number of concerns from our customers. Where do we get started? How do we get these devices onboarded to the internet quickly? So within that pillar, we have 3 different ways we are helping our customers. So first is simple devices. It's complete hardware software offered by Amazon. And earlier today, we announced IoT Button Enterprise program. I'll talk about that in a minute, but you can see on the left-hand side of me. The second way we are helping our customers is if you are having to build your own devices. So then we have a number of partners. We offer the starter kits, and then we offer something called IoT Device SDK, and we'll talk about that. And then finally, our CEO launched a new service called AWS Greengrass, and we'll talk about that. But essentially what we are doing is a number of customers are asking us that solutions are not all built on the cloud, and they need to actually have end-to-end offering. So we'll get into that detail of what we are calling it IoT at the edge. So let me begin by getting into the simple devices first. So this is our simplest offering, what we call simplest way to build end-to-end solutions. And the way we started it last year, we put an experimental device called IoT Button, which shown on the left here, to your right. And our idea was to give this device to our developers that who wanted to learn cloud programming and understand what it takes to, once onboarded the devices, what it takes to collect the data and program and how to use various services. And the reason we offered it that you didn't have to worry about hardware or embedded software that's needed to actually connect. So we were actually overwhelmed by the response we got from both developers and enterprise customers. And they wanting to actually go from the experiment quickly to actually deploy. And we'll get into the details what we have. So I'll give you some quick update since we have launched what are the updates on developer program first. So first, this button is a Wi-Fi based button, and simply when you click it, that click will be registered in the cloud, and then you can take any actions or you can launch services based on that click. It's one of the other things we are doing now in this show is launching a mobile app. And before this, you would have to be understanding how to go onto the web console, and then it was meant for the developers, and it was not necessarily all easy. Now with this mobile app, which is available both on Android and iOS platform, you could simply take the button while still in the box. You could register and configure and set the action that you want it to take place when you press the button. The other things we are also offering is what we're calling it Lambda blueprints. These are the set of programs that you want to have executed based on the trigger from this button. Things like you want to send a text message to you, and a lot more complex things that you may want to do, including invoking third-party API or your own customer database API if you choose to do so. These buttons are available, and Amazon.com has been available. What new things we are offering is there's a new button we are working on, which is available for the pre-order today. Start shipping in February. Many of you have asked us to increase the battery life. So the original button, you could do about 1,000 clicks. The new button will be more than 2,000 clicks. And if you want to actually get started now, and you want to start with our original button, we would be offering you $20 credit in AWS account if you register that, if you buy the old button. Now, there's a link at the bottom of this page. If you want to learn more about the developer program, please visit that page. Now, this is the very exciting piece that I wanted to talk to you about. As I mentioned earlier, some of our business customers want to use this button and launch a specific service at a scale. And so what we are introducing in this conference is you will be able to order buttons at bulk. You could upload your customized graphics, which will be your label or your logo that can be printed on the button. This will be pre-provisioned from security from your account. And we will also offer help architect the solution that you're putting together. Some of the examples that our customers are already doing that, I don't know how many of you attended the State of the Union, IoT State of the Union, presented by Dirk, where you may have seen a Miller Coors example of ordering emergency beer, if you will. So here are some of the customers listed who are working with us in finding innovative ways to develop solutions around this simple device. One of the, so if you're interested in exploring the preview program, there's a link at the bottom. So if you sign up, then we can go forward. So from here, one of the things I wanted to talk about is what our customers are currently doing. When Dave Krumbacher from Eli Lilly approached us earlier this year with some innovative ideas, we were really, truly excited about that. So please help me welcome Dave to tell us what they have done at Eli Lilly. Dave? Yeah.
Thanks, Santiam. Eli Lilly and Company is a global research-based pharmaceutical company, and our objective, our mission, is to create medicines that help people live longer, healthier, and more active lives. In the clinical innovation group that I'm a part of, we are working to make clinical trials a more accessible healthcare option for patients, their supporters, and healthcare providers. The labs team that I'm a part of within clinical innovation has a great opportunity, and we are working by using design thinking approaches, agile methods, rapid prototyping to elucidate ideas, to inspire others, and to bring to life possibilities to improve clinical research. Now, clinical trials, the current state of clinical trials has a lot of room for improvement. They are typically site-based, which means that a patient, whenever they're in a clinical trial, they have to make a visit to a physical investigator location. Many times they're using a device, and if they use that device, that they have to keep manual logs of data and bring it into the investigator site. So they're not very well connected. But what's emerging, what we're working on, what others in the industry are working on, is to bring the trial to the patient, to make it more connected, to make it more convenient for the patient. To bring that to the patient allows them to be more connected within the trial ecosystem. Think of it as IoT meets the patient. And so the objective of our organization is to bring these ideas to life and to demonstrate what's possible. So recently, we had the opportunity to develop a prototype system that would be an activity-based trial management system that we were going to demonstrate. We needed the ability to demonstrate it without actually testing it on patients. This was a simulation. So we needed to act quick, and we needed the ability to virtualize a device. In this case, it was a blood glucose meter. But we weren't in the position to take actual biometric readings because this was a simulation. So we needed to virtualize that device in that process. But we didn't want it to be a complete smoke and mirrors. We just didn't want it to be a fake device that a user in our simulation would just hold on to. We wanted to prove that whenever some action was taken on this virtual device, that there would be data that would be moved through a system, that we could prove that we were interacting with data that was coming from that device. So we first started with some early prototypes. We started with an Arduino-based device getting started in this, and we're sort of a maker shop, and we have a design group and designers and engineers, and so we decided to try this. And while we could technically make this work, the network connectivity was not real robust, so we quickly moved on to a Raspberry Pi. Now, Raspberry Pi gave us a tremendous amount of connectivity and functionality over the Arduino device, but it was more than what we needed. Full entire operating system on it. Its form factor was a little large, and it would still be up to us to instrument it into any sort of platform that would manage the data. So enter the IoT button, and so we decided to give this a try. And it did solve some problems for us. One, we had very good luck on network connectivity with it. Secondly, the form factor was much more amenable to us. But most importantly, it did give us immediate, simple access into a platform, the IoT platform, in order to manage the data and to integrate it into the rest of our simulation system. However, there was one problem. That device does not look like a blood glucose meter. So what does an innovation team do when you need something that doesn't exist? Well, you create it, you make it. So we designed an enclosure to put around the IoT button that would make it look much more like a blood glucose meter. Again, this is just for a simulation, but it does matter for us to be able to create something that's a little bit more lifelike. And not only that, we have a 3D printer, so we took the design and printed the enclosure, and then a couple hours later, we had a final product that looked a lot more like an actual blood glucose meter. So that's a little test strip on the side. It's a complete fabrication, if you will, but under the covers is the IoT button that allows us to actually act on the button whenever it's pushed. Not only that, we also built some applications around this activity-based trial system that integrated with the button. So we had a team of developers to build that, as well as not only a web-based application, but a mobile app as well. And so what this solution architecture eventually looked like was, to our simulated patient, the user in this case, they had the button, it was encased in that enclosure, and then they had a mobile app. And the mobile app instructed them, now is the time to take your simulated blood glucose reading. So we told them to push the button. And when they do that, it publishes to an IoT topic. And then from the IoT topic, we created a rule that invokes a Lambda function. And then in that Lambda function, we have the ability to have our application logic as part of our larger system to decide at that point on the simulation whether this is a normal blood glucose reading or an abnormal reading. Again, remember, we're not taking actual blood, we're simulating an environment. And so based upon the logic, it turns around and publishes the value back to a separate IoT topic. And then that IoT topic is being watched by the mobile app, and then that mobile app then displays the information that came as a result of the Lambda function. So this is a picture of what we call a proving ground session. So I run in our lab a proving ground as part of our design thinking approach of testing out ideas where this entire system, a web application, as well as the patient app that runs on the phone and the IoT button makes for a complete experience that we can take someone through in a very short amount of time. And the key thing that Satya had said earlier was simplicity. Simplicity is extremely important for us to be able to work on our business problems as opposed to worrying about all the little details of getting that one device as part of that larger proving ground session. So with that, we were able to move very quickly. So thank you, and I will turn it back over to Satya.
All right. Thanks, Dave. Wow. Right? It's really truly inspiring how they took this simple little device and created something we couldn't have imagined. We have a number of other customers who have very exciting use cases. I welcome you to actually sign up if you're interested. So let's move on to the second set of tools and products that we have to help you quickly put together a basic solution and move on to your actual customer problem that you're solving. So in this one, we offer two different things to get you quickly started. We have a number of partners who have put together hardware and software solution that out of the box connect to the AWS IoT. There are a wide variety of operating system environment, chipset environment that you can find. And so if you were to quickly prototype a IoT device, this will be one of the options to you. The other option is if you're already in the works and you have an existing device that you have been working on, you can use our IoT device SDK. It comes in 7 different languages, C, C++, Java, you name it. And also we offer a couple of mobile platforms, and similar to what Dave was showing, the mobile app. So if you have the mobile app, need for developing a mobile app, and that app needs to interact with your devices, we offer that SDK as well. Here are some of the examples of the customers, our partners who have worked with us since the last year's IoT service launch. And as you can see, pretty much all chipset vendors that you may need to work with, they are all represented here. And once again, some of these products are available on Amazon.com. The key characteristic of all of these starter kit is out of the box, they will connect to AWS IoT, and then you can prototype your specific examples very quickly. There's a link at the bottom of this chart, so please visit that if you are interested in exploring this further. One of the things that we were lacking in our starter kits was communication choices. All of the kits that you see here are based on Wi-Fi. So we have been working with AT&T on developing a cellular-based starter kit. So please help me welcome Andy Dodlin to help us tell us what they're doing on cellular kit. Yeah.
Thanks, Sachin. Thank you. Well, I'm Andy Dodlin. I'm the Vice President of Cloud Networking at AT&T. And several weeks ago, we announced an expanded relationship with AWS designed specifically to bring to market and to our customers solutions that cross network and cloud and that are simple to use and very flexible, agile, and highly secure with enterprise-grade reliability and performance. There were actually 3 areas, if you read those announcements, that we said we were going to work on together. One was cloud networking to Amazon's robust cloud environment, and we'll be rolling out offers along those lines that are end-to-end solutions. Second area was security, to bring the best of network security along with the best of cloud security and to provide end-to-end highly secure solutions. But today I want to talk about the third area and do it with a demonstration that's IoT related. And to make IoT usable, because it can be somewhat of a complex area, it's very important that it be easy to set up, easy to configure. So what we've worked on with AWS and what we'll be launching into the market very soon is a solution that's a pre-configured integrated setup across the AT&T LTE network and the Amazon cloud environment. So let me talk through first pictorially what will go on, and then we'll show you a demonstration of it. But first, it starts with a starter kit, and you put that starter kit in your device. The starter kit looks like a Raspberry Pi and has the communication software necessary to communicate across the network. And it goes across AT&T's mobility network. And that's very important that it's across the cellular network, the LTE environment, because it's a highly secure, ubiquitous access environment where you don't have to be subject to the challenges sometimes of Wi-Fi, of coverage of the Wi-Fi or security. And then that connects automatically out of the box, pre-configured to connect to the Amazon Cloud Services environment, downloading the security credentials, doing the handshake, and getting a highly secure connection between. So the intent here is something out of the box that's easy to set up and install, and then take advantage of the richness of the cloud capabilities in AWS for IoT. So we'll do a quick demonstration, and to start with that, Rich Finn will be the merchant that sets up first a mobile kiosk. And the first thing that happens when he puts it in place, and we should put the up on the screen, hopefully if we can put up on the screen the picture of the mobile app, the cloud application, and the kiosk. Maybe we can't do that. Can we switch to the other screen? Here we go. So the first thing, and unfortunately since the screen wasn't set up, you didn't catch it all right away, but when Rich the merchant put the mobile kiosk in place, the first thing that happened was it sent an SMS up to the AWS cloud asking for a secure endpoint token, does that handshake, sends it back, and authenticates, and now you've got a secure connection between the mobile kiosk and the AWS cloud environment. The second thing you would have seen is it started empty, and the picture up there would have been empty in terms of the inventory on the top left. But as the merchant, or Rich in this case, stocked the mobile kiosk with an AT&T starter kit, with an Echo Dot, those components then show up in the app. So me as a consumer, I can go over and have access to that simply by opening the device. Oh, it's locked. So I need to get that handy dandy mobile app and unlock it. Now you'll see it's unlocked on the screen, and I can open it. Now, if I take a device out, or a box out, let's pick something good here since I hopefully won't return it. I take out the Echo Dot, and you could see it disappeared on the screen, managing the inventory. And it can close up, and it could be locked again. But this enables, this is just a very simple use case, but hopefully you can imagine the many things that could be done in terms of inventory management, controls, temperature monitoring, whatever. All the capabilities in the AWS cloud are now accessible in a highly secure, good performing way over the AT&T LTE network with ubiquitous coverage, and also in a way that's very accessible. Anybody could set this up. You saw it. You just turn it on, it does the handshake, and it's connected, and you have access. So with that, I will turn it back over to Sachin. Thank you. Thanks, Rich.
All right. Thanks, Andy.
Thank you.
Wow. So we are excited to have this starter kit part of our offering. It's still under works, but if you want to learn more about it, there's a booth listed here, so please visit. Okay, that brings us to the third way we are able to help our customers, and which is what we are calling it IoT at the edge. Number of our customers told us they have application that rely on an infrastructure that cannot all be hosted on the cloud. For example, you may have an oil rig out in the ocean, factories. Some of these applications require a local computation and local intelligence. So earlier today, our CEO announced a program called AWS Greengrass, a product and service, so we'll get into the detail. So let's step back and see what we have offered before to the point today's announcement. So last year we announced AWS IoT Service, which is a cloud platform which allows the devices to connect to the platform securely, register security, take actions on this, analyze the data that's generated, and also access the different web services that are part of Amazon Web Services, including your storage, or as you can see on the slide, there's a AWS Lambda function mentioned. This helps you build the complete solution. We also have offered a device shadow capability. What it does is, if the device is not connected, you could still interact with it. The mobile applications or other applications could still interact with it and change the setup. So from there, what we have done with the introduction of Greengrass today is offer a set of AWS IoT and set of AWS services onto local on-premise devices. You see there's a logo onto the very right on this slide, which is the Greengrass. So Greengrass core runs on any Linux-based device. And what we offer is a secure local connection, the messaging between the devices locally, also the local device shadow, so you could represent the state of the device locally, and the Lambda programming environment. And this is basically provides a single programming model between device and cloud. And this is the way our attempt to simplify. When you are building an end-to-end solution, we started with the end-to-end solution problem. This is our way to simplify that programming and setup that you need to do. So what function and programs that you write on the cloud, direct from the cloud, you can actually deploy locally on the Greengrass core, greatly simplifying the way you want to put end-to-end solution. So let me walk you through some more details. I gave some examples why some of our customers are looking for a solution like this. So there are three main areas that we heard from the feedback from the customers. First one was many applications require real-time responses and the decision-making capability. So once you have the logic written and tested on the cloud, you can actually deploy that same logic locally and it will function as if it's working in the cloud. The second requirement we heard, in many cases, the data has to be processed locally, sometimes because of the privacy requirements or the other regulatory requirements. So this also allows you to now process the data and then take that action locally while keeping the advantage of the cloud intelligence that you get. And then the last one is availability of the connectivity. Some of the remote areas like mining or oil well in the ocean don't necessarily have the big fat pipe or the reliable connection that's always available for these things to work. So in that case, Greengrass gives you the capability to run locally independently even if you lose the internet connection. How it works. So Greengrass, we're working with a number of partners. With them, we will have the Greengrass built into the devices, or if you have some install based, it could be also installed later. As I mentioned, the management and overall solution is defined such a way that you do not have to worry about different boundaries, where are the on-premise and what goes on the cloud. So you manage and deploy all the services from cloud, common programming model, same security principles that we have used so far in our IoT services. So same X509 based TLS security for local devices as well as communication back to the cloud. I talked about local execution and the messaging that is essentially that runs independent of the cloud. And most importantly, the states and some of the other intelligence that you are able to analyze and produce from the cloud, you can use that to change what happens locally. So essentially what we are trying to bring is balancing the need for local execution, need for real-timeness that you need for certain application, but not lose the benefit of the clouds and benefit of the processing that you do on the big data. So this is a preview announcement today, and if you're interested, please go to the link that mentioned below to sign up. So from here, I would like to introduce one of our customers who started with us on AWS IoT. So please help me welcome Fabio from Enel, and he'll help us tell us what they have done so far and what's their plan. So Fabio.
Good afternoon. The Italian guys always have them. You who were lucky enough to wake up at a decent hour this morning, and I was not. Enel, it seems that we are missing some slides, Satyan. I will tell you if you change the slide, I will go on speaking. Enel is a big utility which features almost 90 gigawatt installed capacity and 40% of that coming from renewables, 1.9 million kilometer distribution lines, and more than 61 million customers. Fortune magazine listed us as number 5 out of 50 companies in the company that can change the world list. We believe that energy is a very important service to play a role in nowadays society. And yes, we have always tried to be as smart as we can, at least. And one way to prove it is that almost one-fourth of the smart meters which are installed in the world has something to do with Enel. In the past few months, we spent a lot of time playing with AWS services, trying to migrate servers to the cloud. But what I would like to focus on today is what we are doing with IoT. The meaning of IoT for our utilities and for Enel in particular is enabling the rise of an ecosystem of energy management services. And energy management services as a solution need a platform to grow. And we elected AWS IoT as the platform because it is scalable, reliable, and integrated. There are many examples which I could make of energy management services, just like, for example, storage standalone, storage linked to a plant, virtual power plant, microgrids, home-to-grid, things like this. Today, we will focus on one very simple use case, the connected home. Yes, because our home give a wonderful opportunity to install sensors and to build intelligence upon that. And this is interesting for a utility like ours, which is blessed to serve over 61 million customers. I see that my slides are not going to change, so I will go on with an old version of the presentation. I hope I won't say something wrong. The idea is that we are still an energy company, so we will put one sensor which is typical for us, a clamp, power clamp, which is able to detect power consumption and send it to a gateway which has a light on it and easily can monitor your energy behavior, and also power alert, so that when you're consuming too much, it gives you an alert. Then all the data and the stuff gets through the internet of the home, through the internet connection of the home, can easily go to the cloud. On top of that primary sensor, which is the clamp, many other sensors can be installed. For example, motion sensors, cameras, and things like this. The architecture is very simple, I would say. We have the gateway, which collects the data of the clamp and all the data coming from the sensors, door opening, door closing, and things like this. Everything is then sent to the cloud through AWS IoT. And from the cloud through an Accenture component called CPaaS, it eventually lands on an application. The application may be a web interface or a mobile interface. Let's see what happens after. OK. The application is already launched. We launched it 2 weeks ago in Italy, and it is going on in these days. What we are telling you today here is that probably there are many room for improvement in this case. And one of these is edge computing. Because we are interested in this. Why we are interested in this? Because in certain cases, some decision can be taken locally. And if you can do it locally, then you have obvious advantages in latency and availability. You can also ease the troubleshooting when you have local problems. So you have a reliable interaction when you have a problem which is bounded to your home. Eventually, convenience is another reason, and lower cost, because in cases when your sensor generates a lot of data, you don't need to send them all to the cloud. They can be easily pre-processed locally. So what I'm happy to share with you now is that, as you maybe have seen, I've noticed this morning in Andy Jesse's presentation, Enel will be one of the early adopters of green grass technology, and we are going to use it in this application. I appreciate your time. Thank you. Ciao.
Thank you, Fabio. And sorry for some mix-up here with the slides. We'll get the slides fixed before we post them. So I would like to move on and invite another guest, Art Miller from Qualcomm, and describe how Greengrass is being integrated into the Qualcomm platform. Art.
Thanks. All right. I think I'm on. Thanks, Sachin. First, I'd like to start by thanking AWS IoT team for involving us in Greengrass a little while ago. It's been moving very quickly. We're excited to be working with them. As Qualcomm, we like to connect things. These guys are making it easier to connect things, so we're excited to work with them. Trends. Things are getting connected. Things have been connected for a long time. Right now, it's been difficult to get the data from there. People start looking at, why do we want to connect dumb devices at the edge? The data is valuable, and there are more things getting connected. Exponential growth at the edge, which means exponential processing of data. And moving the processing of the data actually to the edge solves some problems. You've heard over and over latency, security. Those are a few of the problems. The other one is cost. The processing stuff at the edge versus doing everything in the cloud. You save on transport, you save on cloud. So there's the third component, which is cost, that comes into play. As we connect billions of devices, it's not realistic to believe everything will be processed in the cloud. So we've been following this trend with our Snapdragon processors, built on probably the biggest platform ever, the smartphone. We believe we have enough processing power to do a lot of things at the edge. Now, it hasn't always been easy. With AWS Greengrass, it's enabling people who may not have been able to do something or figure out how to connect things, or maybe force you developers to develop a local system and a cloud system. It's a very challenging deployment. So now you can run things at the edge just like you would build it in the cloud. So the trends justify what's going on today. And I think what AWS announced today is reinforcing that. One of the things, we have a use case. So Qualcomm has a lot of employees. We have more than 30,000 employees spread throughout the world, the majority of which sit in San Diego. We have our own bus fleet in San Diego, and we had our engineers write an application to be able to track the bus, see what the schedule is. And one thing that was missing, they were trying to figure out, is there going to be a seat on the bus if I show up to the bus stop so I can make it to my meeting on time, or do I start walking? So one of the things we wanted to do was look at this and say, okay, can we do something in the cloud to detect how many people are on the bus? The example we did, we streamed a bunch of video back to the cloud, did analysis. all to figure out, hey, the bus isn't full, there's a seat, and it ties into our application. Now, that becomes very expensive. Now, the good news is we didn't do this for a very long period of time, and we do have some money to spend on R&D, but I don't think it was $1,000 a day to be able to tell a few engineers that they're going to miss a bus or make a bus. It was worth it. So one of the things we did do was take advantage of our Snapdragon processor and do some analysis on the edge. Do local analytics of the video, and then just stream back the information. We really only needed to know there were 9 empty seats on the bus. We didn't need to have, megabytes of information streaming back for local cloud, or for cloud to make decisions locally. So this is one thing we did. This some time back, prior to Greengrass. And it was more justification on our side that we could do it, and to show that there's trends and there's a solution to the trend, and primarily from a hardware solution from our side. The good news is, now that Greengrass is available, this is something that allows developers to solve for equations like this, for problems like this, much easier. As you're developing your AWS IoT solutions, now you can take advantage of edge processing. You can take advantage of the, the availability of cheap processing power at the edge to lower your cost. You can, the benefits of latency. You hear, latency is a big deal in some solutions, not in all. But the big thing is the network continues to function if there's no connectivity. So you can actually make decisions, take advantage of the processing power, and deploy something that makes sense at the edge versus just in the cloud. One thing Dirk mentioned during his State of the Union was the fact that they're providing a service. It's bring your own hardware. Well, what Qualcomm's doing is bringing the hardware, enabling the hardware for you, pre-integrating Greengrass on our solution. We have it working right now on the Dragon board, 410C, and we have the intent to port Greengrass on more of our solutions as we move forward, both edge-aware solutions and the Greengrass, or Greengrass-aware and Greengrass solutions. One thing, we partnered with a company called Solstice. They're going to be doing it. You have an opportunity to see their demo both in the local area right over here and then over in the main expo area. And what they're doing, something very simple, is looking at sensor data, analyzing that sensor data, and providing some sort of heat map. It's looking at sound, it's looking at temperature, and it's looking at motion. So now, from a facilities management perspective, they're able to look at where's the traffic, where are things getting hot, where are things getting cold, where are all the people, where's the noise. And what they've done, they've taken an Arduino board with sensors that is Greengrass aware, and they're running Greengrass on our Dragon board 410C platform. And they're showing the benefits. They're doing two things. One is showing data locally and data through Greengrass, and the other going direct to cloud. They're showing the benefits of latency, and they're also showing the benefits of cost. The cost I mentioned earlier of instead of streaming everything back to the cloud and operating there, making some decisions locally and just transmitting information back to the cloud. So if you get a chance, please stop by, check out the demo, talk to the guys who put it together, and figure out the problems they're solving for. And the beauty of IoT, I mean, IoT has been around forever. It used to be called M2M. M2M's not sexy. Before that, it was, connected things, and the power industry has probably had more connected to things, for hundreds of years than anyone. But now it's accessible. It's accessible because of what AWS team has been doing. It's accessible because of platforms we've developed from a smartphone perspective. And it's also accessible from the carriers. Things that, that combination, it's kind of the perfect storm where things will become real now. Things have always been connected, but no one was running around talking about IoT or talking about billions of devices. So this simple use case is something that people in this room will take, solve other use cases, and then transform IoT. So we're excited to be part of the Greengrass announcement. We're excited to have a hardware platform that'll enable the edge, and we're excited to work with partners such as Solstice to demonstrate that. So, Satyan, thanks for your time.
Thank you, Art. So here's the booth number listed here on the slide, so please do visit. And we look forward to continue our partnership with Qualcomm and bring out more and more solution offering to you. So that brings me to different customers and partners that have already worked with us. So in terms of customers, we have Technicolor, Philips, and you saw the example from Enel. There was a JPL demo in Dirk's announcement. Then we have silicon partners like Qualcomm, Intel, and Annapurna. And it's not listed here is Canonical Linux operating service software provider that's also have partnered with us to get the green grass up to this stage. So that brings me to the point where we started our journey in this session, which is how do we connect the dots? You are facing your own business problems, and you want to actually focus on solving your business problems as opposed to having invested into what we call it undifferentiated development, whether it's the hardware devices that you may have to build, the cloud services, or other things that you needed. So I hope we gave you the glimpse of some of the products and services that we are offering to get you started quickly. So with that, we come to an end for this session. So thank you very much. If you have any further questions, my email is listed on this. And please, before you leave, if you so kind to fill up the evaluation, we'd really appreciate it. And some of us will be here in case you have a question. Please come up to the side and we'll take your questions. So thanks again. Thanks for coming.